So continuing with the timeliness of prefetch, so this diagram just shows what are the number of memory accesses in certain units of time. So for example, here without prefetching, we've completed 3 memory accesses and the total units of time is 31. Whereas here we've completed the same in about 19 units of time. We've completed the memory accesses here. Also, I think the final memory access, also, although the prefetch has started here at 19, we've actually completed it only at 23. So this should be about 23 units of time we've completed the memory access. So similarly here we've completed the memory access at 36 and not 31. So 31 is where you have issued the memory access request. 36 is when you complete. So anyway, overall, the time taken for the memory access, although the actual memory access time is not reduced, but from the processor's point of view, it has done more accesses in lesser amount of time with prefetching. So let us first discuss how do we do software prefetching and what is software prefetching for loops. So here we are assuming that we have a cache with 4 word blocks for the first case, wherein we are going to fetch a of 0 to a of 3. So this is also a kind of prefetching, because in case of a cache which has 4 word blocks, when you request a of 0, you're also going to bring in a of 1, a of 2 and a of 3. And so that is also a kind of prefetching. So although you do not have an extra prefetcher or a prefetch buffer, in a case of a loop like this, uh, the first case of a of 0 would be a cache miss. But then later on, for a of 1, that is the second iteration, third and the fourth. So for a of 1, 2 and 3, there will be cache hits. And then a of 4 will again be a miss. So when you miss on a of 4, you're going to fetch 4, 5, 6 and 7. So basically every fourth iteration will be a miss. Now, in the case of a prefetching, what the compiler can do is it could add in prefetch instructions such as this. So basically, it tells us to fetch a of I plus 1 when when the loop iterator is I. So, for example, if the loop iterator is 0, currently if I equals 0, then it's actually fetching a of 1 right at that time. So basically, the it's going to if you again assume that it is going to fetch in 4 word blocks. If you combine the concept of prefetching with a cache with multiple blocks or 4 word blocks, so basically, A of 1 is going to fetch A of 1, A of 2, 3, and 4. So, uh, so that is how we should interpret a prefetcher with a cache. So basically, even if we were not using this 4 word cache blocks, what this essentially means is that whenever I'm accessing A of I want to prefetch the next one. And whenever I were to use A of 1, I'm going to prefetch A of 2 and so on. So this kind of a prefetcher is called a next line prefetcher, because every time we are going to fetch the next one ahead of the request. So similarly, you could also do unrolling of the loop. So basically, instead of just fetching A of I, sorry, instead of just accessing A of I and computing with A of I, we could compute with I plus 1, I plus 2, and I plus 3. So this is basically loop unrolling, and therefore the iterator is going to increment by 4 every time. And similarly, in this case, if you were to prefetch instructions, you'll have to prefetch from I plus 4 onwards. So you could this actually is very useful. Combining prefetching with loop unrolling is going to be very beneficial. So similarly, another example of software prefetching with loops. This kind of a prefetching works very well with loops and also with regular access patterns. So what that means is that earlier we fetched I plus 1 all the time, and the loop was also always incrementing as I plus plus. So in such a case, if you were to do a next line prefetching, that's going to be very useful. But let us look at another example here. So here, let's say, for example, instead of always prefetching I plus 1, I could prefetch I plus k, wherein k is a certain stride or a prefetch distance. So what that means is that I could choose I to be 1, in which case I would call this as a next line prefetcher, or I could choose the k to be 2, in which case I'm going to always fetch k elements ahead. So what is the advantage of doing this kind of a prefetching? So this kind of a prefetching is also called as stride prefetching. So again, we're talking about software prefetching, which means that this is a prefetch instruction added by the compiler. So for example, if I choose k equals 7, then I equals 0 to 6 iterations will be misses, whereas I equals 7 onwards would be a hit because I have already prefetched prefetched that particular data. So a of when you're accessing when I is 0, I have actually prefetched a of 7 if k is equal to 7. So that means when the loop comes over and accesses array of 7, I have already got that data here, so it would be a hit. So there are cases where stride prefetching is useful, but then it's important to find out what is the ideal value of k you would like to use. So for example, continuing with the same loop that we had, so let us say I make k equals 1. So, and the so this is prefetching a array of 1, and I am currently accessing array of 0. So I have prefetched array of 1. Now, by the time this loop comes back and starts the next iteration with I equals 1, I'm going to be prefetching a equals 2. But more importantly, I'm going to be accessing a of 1. So I need to make sure that this a of 1 which was prefetched in the previous cycle is available by the time the next loop iteration starts. So basically this is what is called timeliness, which we went through earlier. So when I have a stride of k equals 1, I need to make sure that I'm prefetching a of 1 much ahead of time, or at least in time, by the time I actually use it. So if I'm prefetching a of 1 at this point in time, so when is it going to arrive? So if it is arriving late and I actually need that at this point in time, that is not going to be useful. Similarly, if I use k equals 20, then that means that I'm going to be prefetching a of 20 when currently my loop is iterating at a of 0. So this might be too early because I don't need a of 20 right away. So we need to be able to predict what k is good enough. And we should also combine this technique with loop unrolling so that we get the maximum benefit. So how many iterations ahead should I prefetch? So typically you can use a simple equation like this, L by S. L is the average memory latency in terms of processor cycles. So when we looked at the uh, diagram here, this is the latency here. So we have to make sure that that average memory latency in terms of the processor cycles is taken care, and also divide that by S. S is nothing but the shortest execution time of one iteration. So, for example, if you're going to take 5 cycles of memory latency to return that data back, so this is 5 cycles, and 1 cycle is the time taken for that for loop to uh, iterate. So then essentially you should um, prefetch the data at least 5 iterations ahead. So to explain this equation a little further, so let us assume that we have cycles 1, 2, 3, 4, and 5. And let us say I'm currently accessing a of 1 at this point in time. And I'm in that loop which is operating on a of 1. And let us assume that it takes 1 cycle to operate. which means that in the very next cycle, I will be using A of 2 and operating on A of 2. So at this point in time, let us assume that I issue a prefetch for A of 5. Now, this is going to take 5 cycles to arrive, as according to this assumption. It's going to take 5 cycles to arrive. So, which means that it is going to arrive at this point in time. So, this is when I actually need A of 5. So, it is going to arrive just in time uh, by the time I actually compute on A of 5. So, that is why we said that we need to prefetch it L by S iterations ahead. So let us assume another example. Let us say that the memory latency is about 6 cycles. And let us assume that I'm in the first iteration, I'm operating on A of 1. And this is going to take 2 cycles to complete. So that is this S, which is the shortest execution time of one iteration. So let us say that it's going to take 2 cycles to operate on that A of 1. So this is basically one iteration of that loop. So then A of 2 is going to get operated in the next 2 cycles, A of 3 in the next, and so on. So 7, 8 is A of 4, and 9, 10 is A of 5, and so on. So now let us assume that we need 6 cycles to fetch the data from memory. So when should I prefetch A of 6? Is the question. Let us say I want to prefetch A of 6. So should I prefetch A of 6 at this point in time? It's not needed because it's going to arrive 6 cycles later, that is right here. But I actually need it in cycle 11. So it is good enough if I just prefetch it just a few cycles before that. So which is essentially somewhere here, which is 3 iterations before it's actually needed. So, so that is how you actually figure out L by S iterations ahead. You need to just prefetch that data. So, what is the disadvantage or limitations of this software prefetching or prefetching in general? Is it works very well for regular and predictable array accesses. The disadvantage is that with all of that loop unrolling and extra prefetch instructions, the code is expanded, and then you have more instructions in the code now. The other disadvantage is that if you do it in the compiler, the compiler does not exploit any runtime information, and the programmer also might have to do it manually. The programmer could add those prefetch instructions manually, and when you do it statically, you do not have runtime information. Therefore, um, it may or may not work at the best performance.